Welcome to Unclass TV. I read myself Alewi Tosin. Now, to continue, this is electricity part 2. Now, let's continue with galvanometer. What is galvanometer? Galvanometer is an instrument, it's a device used for measuring very small amount of current. It's an instrument used for measuring what? For measuring very small currents. Very small current. That's what galvanometer is used for. And it measures in milliampere. It measures in milliampere. Galvanometer measures in milliampere, while the voltmeter measures in what? In ampere. The ammeter measures in what? Ampere. The ammeter measures in ampere, while the galvanometer measures in what? Milliampere. Now, let's consider potential difference. Potential difference. Now, what is potential difference? Most of us write it as PD, potential difference, and while in application, while doing calculations, we write as what? As V. Now, what is potential difference? Potential difference between two ends, potential difference between 2 points, let me write this way, between 2 points, 2 points now, is the work done. Is the work done? Work done in moving a unit mass of charge, in moving a unit mass of charge from one point, mass of charge from one point to another, mostly from lower potential to higher potential, mostly from higher potential, mostly from higher potential to lower potential. Now, potential difference is measured in volts. It is measured in volts. That's V. Potential difference is measured in volts. That's V. And we say that it is given, we can say that work done in moving a unit mass of charge from one point to another is given as what? We say it is V times Q. That is what? Let's write it as quantity of charge. Quantity of charge times potential difference. So our work done here is what? Is equal to QV. Our work done is QV. Work done is QV, where your Q is the quantity of charge and your V is what? Is the potential difference. Now, we can recall that Q, we said it in our last class, that Q is equal to IT, which means we can say that what work done is equal to what? ITV. Where our I is equal to electric current, our T is the time, while the V is the potential difference. Okay, let me just write as PD. potential difference around the what? The point. Now, that is that for potential difference. We said is the work done in moving unit mass of charge from one point to another, mostly from higher potential to lower potential. We said it is denoted by what? By V. Is measured by V is measured in what? In volts. And we said work done is given as what? Quantity of charge times your potential difference, which is W is equals to what? QV. And that gave us this formula. We said what? When we record for Q is equals to IT, then we say that what? Our W is equals to what? ITV. Or in most cases, I call it Q is equals to VIT. So let's have that formula upstairs. The first formula we had was what? Q is equals to IT. Second one was W is equals to QV. And the third, another one again is what? W is equals to what? ITV. Now let's take another one. Now let's take voltage. Voltage. What is voltage? Voltage is the potential difference between 2 points. Is the potential difference PD between two points. Is the potential difference between 2 points. Voltage is also denoted as V, and is measured in volts. Voltage is measured in what? In volts. Measured in volts. Now, let's talk about resistance. What is resistance? Resistance can be defined as the opposition. Can be defined as the opposition given to the flow of currents in a circuit. Now, resistance can be defined as the what? As the opposition given to the flow of current in a circuit. Resistance is like an hindrance that obstructs current from flowing directly in a what? In a circuit. Resistance is denoted by R. It is denoted by R. It is denoted by R and is measured in ohms. It is measured in ohms. Which is written like this. Resistance is measured in ohms. It is denoted by R. It is measured in what? In ohms. Now, let's then talk about factors that affect resistance. Factors that affect resistance. Factors that affect resistance. Number one is temperature. Is temperature. Number two, we have cross-sectional area. Cross-sectional area. Number three is the length of conductor. Length of conductor. And the last one is resistivity. Is resistivity. So those are the factors that affect resistance. Temperature, cross-sectional area, length of conductor, resistivity. We'll continue from there in our next class to explain further. I name myself Aliwi Tosin. Thank you.